In our final Q practice problem, we're using the exact same system as in number 3, but now we have different concentrations. So the different concentrations are going to give us a different result. Still following the same procedures, calculating the reaction quotient simply means plugging them into the expression. It's the same one as number 3, so we now find that our reaction quotient is noticeably smaller. Now look here. You have to keep your eye on these exponents because they sometimes can sneak by your notice. So now with this reaction quotient, we come up to the fact that this will shift to the right because now Q is less than K. And I also mentioned that I have to make products while consuming reactants. So even though I've changed my language in each of these, you'll see it's the same pattern for getting both of the points. I first tell you the answer to which direction it will shift. Then I make that connection to the Q versus K relationship and make a statement about products and reactants. Finding the equilibrium concentration of each gas. Again, here's the beginning of it all. We need an ice table. So I put in my new concentrations that were supplied by the problem with the much smaller concentration of NO. I have again changed the sign because now I'm going in the opposite direction. So I have to change my sign and I get my equilibrium concentrations. And now I just need to plug it into the equation. So the K is exactly the same, right? I have not changed K because I didn't change the temperature. Oop. Still a perfect square, still a bunch of math. And now I have my new X. So I get my final point by plugging that in to the relationship. And I get my new concentrations. For every one of these problems, you can do a quick check on your work by saying, let me plug these numbers that I got back into the expression. Let me just plug in the concentration of NO squared divided by the concentration of these two, which would be 0.1599 squared. And if I have done everything right, you will see an answer that matches your K value. This is actually a method I use to determine whether or not I made a little math mistake. Because if I made a little math mistake, if I did plus here instead of minus, I'll get an answer down here when I evaluate it for x. But it will not result in concentrations that match up with my K value. So a quick way of checking to see if you need to look for a math mistake is to plug these numbers back into the equilibrium expression to see if you get the K value that you were told was true.